we'll just jump right in. I've got a quadratic equation. I know it's a quadratic equation. It's in one variable. Our highest exponent is 2, so it's of degree 2. And it's an equation because we have an equal sign. And lucky for us, it's already in standard form. We have ax squared plus bx plus c, and then we have a 0 on the right-hand side. So why don't we just launch right in? A equals 1, b equals 6, c equals 8. And then if I remember my quadratic formula, negative b plus or minus b squared minus 4ac all over 2a, which in this case is just 2 times 1. So we should be getting a little bit more familiar with using this formula. Remember to always substitute in your values in brackets. 6 squared is 36. 4 times 1 times 8 is 32. All over 2. I'm going to simplify as much as I can before I use the plus minus to split the equation. So 36 minus 32 is 4. And I actually know the square root of 4, right? That's just a positive 2. So I have negative 6 plus minus 2 over 2. And now I can split it. So x1, I'm going to take the plus from the plus minus. So negative 6 plus 2 over 2. Or we also have an x2. The second value that x could be, so if I take the minus from the plus minus, negative 6 subtract 2 divided by 2, then I can just go and I can solve these. So that's going to be negative 8 over 2. So my second x is negative 4. And my first x is negative 2. So I've solved this with the quadratic formula. It took me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of algebra. It took me maybe 3 or 4 minutes to do. And there's a risk each step that you make a small algebraic error. So what I kind of want to remind you or show you is that we always have options, or we often have options on how we can solve a quadratic equation. We did to start this at-home unit is I could also have just solved this by factoring. That was a simple trinomial. 2 numbers that multiply to 8 and add to 6. Well, that's going to be 2 and 4. So I've got x plus 2, x plus 4 equals 0. So then x must equal negative 2. That would make the first bracket 0, or x is equal to negative 4. So I get the same answers, but I only use one step of algebra, and I solve that in around 20 or 30 seconds. So this is an example of a quadratic equation where, sure, I can use a quadratic formula. It's always going to work and get me to the right place if the equation is possible to solve, if there are 1 or 2 solutions. But often, factoring is more quicker, more efficient, and we also have a lot less chance of making an error. There are all sorts of places to miss a negative or to not bring the denominator of the fraction all the way across. So we have more chances for error in the quadratic formula. If we can factor in for comfortable factoring, which we should be with a simple trinomial, this can be a lot quicker, a lot more efficient, and a lot more secure. So the point of today's video lesson, which is a short one, that's the only example we're going to do, is kind of talk about when should I solve quadratic equations by factoring, and when would I recommend using the quadratic formula. So again, this would have been, I think, more fun to do in class. We could have brainstormed together, but I'll kind of talk through some of my ideas, and then you could fill in this T-chart on your own, or if you have your own preferences about when to use one or the other. Well, take a look at this example. In this example, it was just a simple trinomial. Simple trinomials, we should be pretty confident factoring. Right? We can factor this by finding the 2 magic numbers, one step, and then we have a solution. So I would recommend solving quadratic equations with simple trinomials. Another place where factoring might work better is if our quadratic equation, so if the quadratic equation has only 2 terms. So that might be a difference of squares, it might be a common factoring problem. Usually there's only 2 terms. It's much more efficient to factor. So, for example, if I have something like 3x squared, let's say plus 12x equals 0. I could use quadratic formula. A is 3, B is 12, C is 0. But it'd be quicker if I took a common factor of 3x. So when I common factor this, I already know that to make this first part of the product 0, x could be 0, or x could be -4. So there's an example of it's much quicker to factor when I only have two terms. It's either going to be a simple common factor, or we could also do a difference of squares, which we, again, should be comfortable with by now. When does a quadratic formula make sense? When is it necessary? Well, the most obvious example, the one we started with yesterday, if it's impossible to factor. So if you can't find those two numbers, if they don't exist, sometimes we have to use a quadratic formula. Not every equation is going to be factorable. If the roots or the solutions are irrational, then we would never have been able to factor. But there are other cases where we might just be more comfortable using the quadratic formula. So if they're very large numbers, I wouldn't expect you to factor. If we're trying to find two numbers that add to 73 and multiply to 612, you might jump right to the quadratic formula. Same thing if we have decimals. So a lot of real-life applications that we'll get into once we're back in the classroom. If you see decimals, we can't factor. We're never going to think of 2 that multiply to 13.5 and add to -2.1. So we're going to, when we have kind of real-life parameters, we often have decimals. We would use the quadratic formula. Another one, maybe I'll put in blue, and this is kind of where it gets into your own comfort. What about complex trinomials? So if you remember from our previous unit or from the work you've been doing over the last couple of days, a complex trinomial is when 8 is not equal 1. We can often factor those, but it might take you 3 or 4 steps of algebra. It might be difficult. So maybe I'll put a little question mark there. So complex trinomials, depending on your preferences, you may actually find it efficient or quick to use the correct formula, even when you could factor. So that's kind of a more personal choice. My kind of advice, so I'll kind of add this here as advice. Factoring is always, again, more secure. There's less chances to make a small error, and it can often save you time as well. So my advice is to spend at least 30 seconds to a minute trying to factor. And if you can't find those two numbers, either because they don't exist or because they're large, or you're just having a block in your head and you're forgetting a certain pair that multiplies to something and adds something else, then I would recommend, okay, sure, let's move on and try the quadratic formula. So we have two methods of solving quadratic equations, and what today's practice is going to be about, and there aren't too many problems, is about you kind of learning for yourself your comfort level with both of these methods, solving by factoring and solving using the quadratic formula. So for question 1, I actually want you to solve both of these problems two ways. First by factoring and then using the quadratic formula. You should get the same answers both ways. And after you're done A and B, I want you to think to yourself, well, what was easier? What did I prefer doing? And then option 2, there's only 6 equations. So for each of these, rearrange into standard form first. And then you choose what you think works better for you, factoring or quadratic formula. If you look at my solutions, you can see what choice that I have made, what I think is going to be a more efficient way to do it. The last thing I'll mention is that for some of these equations, you might find it easier to use a combination. So you might take out a common factor first, get the numbers nice and small, and then plug them into a quadratic formula. So you're welcome to even use a combination, and if you have any questions about that,